Hey there, everyone. Welcome back to some more algebra stuff. This is section 1.3. We're going to be talking about basic algebraic models and their applications. Applications obviously is a fancy way to say word problems, but don't freak out on me. These are very basic, and it's really more about the process of setting things up than it is about how to solve the problems, than it is about the problems themselves. Okay, so the setup is always what gives students an issue. And I'm hopeful that in focusing on this morning, today, whatever, whenever you're listening, that I can show you that if you follow a process, then setting up word problems really isn't that bad. And as the problems get more complicated later in the semester, we'll have this baseline to come back to if we need it. Okay, so today what we're going to do is we're going to talk about two different things. We're going to use linear equations to solve problems. So we're just dealing with the basic equations, no square roots, no x squareds, nothing like that, just basic linear equations. And then also find, taking formulas that have more than one variable in them and solving them for a specific variable. That process is important as well. So we've kind of got both of those here together today. So the step-by-step process, and as I've suggested before, you may want to pause the video at this point and write these down, because I'm not going to just read them to you. You can certainly read, but the really important stuff that you need to be able to do here and that you need to recognize as important that most students don't do is write down what your variables represent. Okay? You have more than one thing you don't know. X is one of those things, and then figure out ways to write the other ones in terms of X also. And the problems you're going to be given have that relationship, and then you have to write an equation. And then these two, this is what we've been doing up till now, right? Solving and checking. This is the basic stuff. These are the setup, right? So this is the setup here. 1 through 3 is the setup. 4 and 5 is the actual algebra. So let's do an example. The median salary of a computer science major is exceeds, okay, more, right, than that of an education major by $21,000. The median starting salary of an economics major exceeds, again, more than an education major by $14,000. Combined, their median starting salaries are combined, adding them together, right? Adding. Their starting salaries are $140,000. So we have three things we don't know. Right? We don't know the education major salary. We don't know the computer science major salary. We don't know the economics major salary. We don't know those three things. But computer science is tied to education. Economics is tied to education. So it makes sense to say X should be the median starting salary of the education major. Okay, now I've got these written out better on the other side, but notice that I didn't say X equals education major, X equals salary, right? It's got to be specific enough so that you don't get confused when you start to write the equations out, all right? So if we go to the next page, you'll see we're letting X represent the median starting salary of the education major, and then based off of what we were told, let me go back to the previous page. Computer science majors make $21,000 more, exceeds. Economics make $14,000 more, exceeds. You got to know the words, right? And so X plus 21, if X is the amount of the education major, then X plus 21 is the amount for the computer science major, and X plus 14 is the amount for the economics major. Okay? So again, you just have to read through the problem. I do not expect you to translate this word for word as you read it along, okay? It's a step-by-step process. And now what do we need to do? Now what we need to do is we need to write an equation that models these conditions. Well, what did the word say? Go back to the problem. Combined. So we got to add together. We're supposed to get $140,000. All right, so we're doing everything in terms of thousands of dollars. This is $21,000. This is $14,000. X is in thousands of dollars. Okay, and that should be noted, to be honest. thousands, all right? Thousands of dollars. So what is the equation that would work for this? Just add them all up. X, right? The first one, X, times X plus 21, times X plus 14. There's the total. So here's your education median, here's your computer science median, here's your economics median, salaries, and then there's the total amount that those add up to, okay? So once you get to here, everything else is just now solve it, just do the algebra, right? This is supposedly, for us anyway, this should be the easy part. All right, so add them together, you got 3 total x's, simplify the left-hand side first, you got 3 total x's, and 21 plus 14 is 35. All right, what are we going to do next? Subtract 35 from both sides. 140 minus 35 is 105, and then we divide everything by 3. And we divide by 3, we get x equals 35. Okay, so now, that has not solved the problem. That told you what x is, but that has not answered the question. What was the original question? If you have to go back and look at the problem again, the original question was determine the median starting salaries of all 3 of these majors. Okay, so x equals 35 is just one part of that solution. You have to go ahead and plug in for your other stuff too. All right, and so if x is equal to 35, starting salary of a computer science major is x plus 21 equal 56, and then x plus 14 is equal to 49. Okay, so that doesn't, again, answer the question completely. I didn't ask you for x. And so $35,000 is the starting salary for an education major. The median starting salary of a computer science major is $56,000 and $49,000. Remember, these are all in thousands of dollars. Okay, and so usually a word problem deserves a word answer. I don't really care if you write it quite this beautifully as a complete sentence, but you definitely need units, 35,000, 49,000, 56,000. All right, and then they do recommend that you go and check. You can check it by adding these up and making sure they add up to 140, but no big deal. Okay, if you've done the problem right, checking it should not be an issue. I'm going to show you one more example, slightly different. The textbook has bunches of examples. You can always watch the textbook videos. They have videos for each section. They'll go through a few other examples. There's all sorts of stuff that you can see. I'm just trying to keep these videos short so that you will actually watch them. So, next problem. After a 30% price reduction, your purchase of a new computer is $840. How much was it before the reduction? Well, X is the price before the reduction. We don't know how much that is. And then 0.3, right, 30% of, right, so they don't mention this, but 30% of X is just 0.3X, right? 30% is 30 out of 100, that's 0.3, and then times X, the of is multiply. So that's your discount, and so X minus 0.3X, okay, that's going to simplify to 0.7X. And so the equation that tells us what's going on here is that x minus 0.3x or 0.7x is equal to 840. Okay? So if you want to solve this, you get 0.7x equals 840. Divide both sides by 0.7. Use your calculator for that. All right? And you're going to get 1,200. Okay? And so the price before the reduction is $1,200. Again, units. Got to have your units in order to be the correct answer. If you want to check it, then take 30% of that guy. Take 30% of 1,200, all right, and make sure that when you take 30% of it, you subtract and you get 840, right? So if you take 30% of $1,200, right, that's 0.3 times 1,200. Do that on your calculator, you get $360. So if you take 1,200 minus 360, again, use your calculator for that part, and you get 840. Okay? So I don't expect you to do arithmetic without a calculator. That's no reason for that, but you should be showing me your work that you're doing along the way. Okay? All right. So if you want more examples, again, you'll find those in your textbook, and I'm always happy to work extra examples during our problem sessions. The other part of this section is working on solving a formula for a variable. Many of our formulas will have more than one variable in them. They represent different quantities, and so we need to be able to do that. Let me show you a couple of examples here. Here's a formula for perimeter of a rectangle. The perimeter of a rectangle is given by 2 times L plus 2 times W. So if you have a rectangle with L and W sides, right, here's L, here's W, then the perimeter all the way around is L plus W plus L plus W, which is 2L plus 2W, all right? But we want to solve it for W. So how are we going to do that? Well, we want to isolate W. If this was a 7, you'd subtract 7 to both sides. Well, that's a 2L. So we're going to subtract 2L from both sides. Unlike when we're working with only one variable, we cannot combine these two. This is P minus 2L over here on the left-hand side. Now you can't combine that because they're not like terms. And then if I divide both sides by 2, the whole thing gets divided by 2. And so we get W by itself, and that is equal to P minus 2L over 2. And remember, this P minus 2L is in parentheses, even though you don't have to write them. It's not wrong if you don't write them. It is wrong if you try to divide these 2's away, because you can't do that. All right, so you get P minus 2L divided by 2, and that is equal to W. That process, all right, being able to do that, it's the same steps, right? I subtract the number that doesn't have a W in it, I subtract it from both sides, and then I divide by 2. It's the same process as if you were solving for W and these were numbers. You just can't simplify the numbers because they're variables also. Similarly here, what happens if you've got more than one C? We want to solve for C here, but there's more than one. Well, we get them all on one side, which we've done already, okay? If this was P minus C equals MC, we'd have to add C to both sides first, right? So always collect all the C's. And now if there's a C here and a C here, what do we call that? We call it a common factor. So factor out the common C. If you divide C by C, you get 1. If you divide MC by C, right, then you get just M. Okay? And so now this is C times all this stuff. How do I get C all by itself? I divide, right? If this was 4 times C, I'd divide by 4. This is 1 plus M times C. I divide by 1 plus M. Easy enough. 1 plus M divides 1 plus M and leaves a 1. And so I'm left with C over here by itself. I get P divided by 1 plus M. And again, you don't need the parentheses, but they are technically there. And so this is solved for C. All right, so this process of being able to solve variable equations for one specific variable, all right, is an important algebraic extension of what we've been doing so far. It's still linear equations. There's no quadratics. There's nothing square rooted. There's nothing in the denominator or anything like that right now. This is just basic algebra applied to a slightly more complicated situation. Okay? So hopefully that helps. Practice both of those in section 1.3. You'll have some worksheets for those and my math lab homework as well. So hope that helps. See you later.